Hi, future doctors. Welcome to the next class. From this class onwards, again we will discuss problems on circular current carrying coil and straight wire, combination of those. So, already we discussed this. If this is the circular coil, if I current is passing, so what is the magnetic field intensity at center of this current carrying circular coil means so B naught is equal to mu naught I by 2R. So what is its direction? If you want direction means, I told you circular coil means four fingers you can take in the direction of current. So current is passing like this, now thumb is into the board. Therefore, magnetic field is into the board. Now, same current carrying conductor, they have given like this. I like this they have given. Let us assume. Then what is the magnetic field intensity at center of this current carrying coil? So whenever straight wires are there, this point is straight to the two current carrying conductors. Therefore, because of these two, magnetic field is zero. Next, this is semicircular arc. So this upper part, semicircular arc means this upper part mu naught I by 4R. This lower part also mu naught I by 4R. But this magnetic field is into the board. This magnetic field is outside the board. Therefore, resultant magnetic field at center is going to be 0. So, blindly we can follow one thing. If entering and leaving currents is given for any coil or triangle or square, whichever it might be. Already in square also we discussed like this. So, this entering and leaving whenever they are asking at center, their magnetic field is going to become 0. You can follow blindly. Next, see this. So this is going to be R1. This is going to be R2. If I current is passing like this, what is the magnetic field intensity at center? They are going to ask. So at the time, because of how many conductors here? Four conductors. One, two, three, four. So these two straight wires. Straight wire. Therefore, because of these two, there is no magnetic field. Now this is semicircular arc. So because of this R1 or B3, third one we are taking. B3 is equal to mu naught I by, this is semicircular arc, 4 R1. B4 is equal to mu naught I by 4 R2. Now what see the directions? Here current is passing like this. Whenever curve is there, we have to follow four fingers. So magnetic field is into the board. So here it is going to be current is like this. Magnetic field is outside the board. Now one is inside, one is outside. Therefore, resultant either B3 minus B4, B4 minus B3. Which is higher? Higher minus lower value we should do. Mu naught I by 4 is common in both. So 1 by R1, 1 by R2. R1 is less. Therefore, B3 is more compared to R2 is more. Therefore, B3 is less. Therefore, resultant is B3 minus B4. So, mu naught I by 4R1 minus mu naught I by 4R2. So, mu naught I by 4 common, 1 by R1 minus 1 by R2. What is the resultant direction? Here B3 is higher, we have subtracted from B3 and we have subtracted B4 from B3. Therefore, B3 is into this direction is also into which is higher, that direction you have to take. Understood? So, same diagram they make you like this. Again, this is R1. This is R2. So current is going to be I. Again, because of these two, magnetic field is 0. So this upper part, B1 you can take. This is B2. What is B1 now? Semicircular arc, mu naught I by 4R1. What is B2? That is also same, mu naught I by 4R2. Now see the directions. Curve. So magnetic field is into. Curve. Magnetic field is into. Both are inside. Therefore, directly, simply we can add B is equal to B1 plus B2. Same answer you will get, but what is the difference? 1 by R1 plus 1 by R2. That is going to be into the board. Understood? See the next problem. So this is going to be straight infinite current carrying conductor, combination of this. And another one, find the magnetic field intensity at center which is at distance r. So current is passing like this, in this, like this. What is the magnetic field intensity at center? So because of infinite wire, this is 1, this is 2. What is the B1 at a distance r means mu naught I by, what is the formula? Mu naught I by 2 pi r. Already we discussed this because of infinite current carrying conductor. B2, circular coil at center, mu naught I by 2r. See the directions. Now it is going to be important. Here current straight wire, we have to show thumb. For straight wires, thumb is going to represent direction of the current. So 4 fingers here outside, but here it is going to be inside. So it is going like this. Therefore, at point O, magnetic field direction is inside. Now see here, whenever curve, we are getting 4 fingers representing current, thumb is going to be inside. This is also inside. Therefore, both are inside means we have to add. B at center is equal to B1 plus B2. Mu naught I by 2 pi r plus mu naught I by 2r. So, what is common? Mu naught I by 2r. So, 1 by pi plus 1. So, how they will give in options? Depending on that, you have to rearrange. 1 plus pi by pi. What is the resultant direction means? Into the board. Now, this is the similar question, small change. They have given semicircular arc I. So, what is the magnetic field intensity at center O, which is at a distance capital R there? Now, this one we can take 1. Now, what is 1? B1, B2. So, for this infinite wire, this point is at one end. At one end, because of infinite wire, what we got? Mu naught I by 4 pi r. Already we discussed in previous classes. What is B2? Semicircular arc. Semicircular arc means mu naught I by 4r. Now see the directions. For straight wire, thumb represents current. So magnetic field is outside here. Therefore, this is going to be outside. So for curve, current is going to be like this, magnetic field is inside. Again, whenever inside outside, one is positive, one is negative. Therefore, one is positive, one is negative means opposite direction means subtraction means B is equal to either you should do B1 minus B2 or B2 minus B1. Which is higher? If you think means here mu naught I by 4r is there. Here mu naught I by 4r is divided by pi. Therefore, which is higher? B2 is higher. Therefore, resultant is B2 minus B1. Mu naught I by 4r minus mu naught I by 4 pi r. So, mu naught I by 4r is common, 1 minus 1 by pi or pi minus 1 by pi. So, resultant at center is mu naught I by 4r pi minus 1 by pi. Now, which is into or outside means we wrote B2 minus B1. Therefore, B2 is higher. Therefore, resultant is into the board. Understood? For the same question, small change I am giving. Like this also, they will give same answer you will get. Why? Because of this straight wire, it is going to be 0. Answer is going to be same. This is the next problem. So this is infinite y. Like this they have taken. Let us assume. Now what is the magnetic field intensity at point O, which is at a distance capital R. Now, because of 1, 2, 3, because of this one, this is infinite wire at one end. What you are going to get? Mu naught I by 4 pi R. What is its direction? Outside. Now what is B2? Circular arm. Current is going like this. Magnetic field is into. Therefore, circular arc means mu naught I by 4R. Magnetic field is into. Again, this is infinite wire at one end. Infinite wire at one end means B3 is equal to mu naught I by 4 pi R. So, current is going upwards, magnetic field is outside. Correct? So, here it is going to be outside, this is inside, this is also going to be outside. Now, resultant of these three. So, B1 and B3 both are outside, therefore, you can add. So, B13 is equal to mu naught I by 4 pi R plus mu naught I by 4 pi R. So, now B13 equal to 2 mu naught I by 4 pi R. So, what is the resultant direction here? B13 outside. Now, what is the net magnetic field at center? B0 is equal to, so B2 is into B13 is outside. Which is higher? Which is higher you have to see. Mu naught I by 4R. Mu naught I by 4R is multiplied by 2 by pi. 2 by pi means 0 point something, 2 by 3. 0 point something, this is 1. Therefore, which is higher? B13 is lesser, B2 is higher. This is multiplied by 1, this is multiplied by 0 point something. So, therefore, B2 minus B13. B2 minus B1. Mu naught I by 4R minus 2 mu naught I by 4 pi R. So, what is common? Mu naught I by 4R common. 1 minus 2 by pi. So, pi minus 2 by pi. Therefore, resultant direction is into, because B2 minus B13 higher value is this. Therefore, resultant direction also inside. So, same question if they give like this. I, this is going to be I. Now again 1, 2, 3. So because of 1, infinite wire at one end. What is the formula? Same, mu naught I by 4 pi R. What is its direction? Current is coming outwards, it is going to be outside. Downwards, outside. So directions are going to be very important. B2, mu naught I by 4R. So current is going like this, inside. B3, B3 infinite wire at one end. Mu naught I by 4 pi R. Now see the direction. Current is going downwards. Here it is outside. Therefore, here it is. If it is coming like this, if you are taking current is going to be inside. So one magnetic field is inside, one magnetic field is outside. Therefore, these two will cancel each other. Therefore, B13 is 0. Now, what is the resultant magnetic field means? Only B2 is present there. So, that is going to be mu naught I by 4R. So, how many problems they gave also? So, with the directions we are going to get the answer. So, infinite wire or wire is there means thumb going to represent current. If curved wire is there means 4 fingers represent current, thumb represents direction of the magnetic. So, try to do some problems on these models. Remaining we will see in our next class.